to all of you. Myself Suraj Soni, and this is the part number 3 of chapter P block. 2 parts is already updated. So first of all, I would like to suggest you watch that video. Then you should see that video, so you can understand very well. In this video, we will talk about compound of nitrogens like acid and nitric acid and some oxo acids of nitrogen and phosphorus and phosphine compound. And see, the first one is nitric acid, Aquia Razia. Third point is oxidizing nature of nitric acid. Point 4, formation of the oxo acids. Point 5, phosphorus acid, in which you will study about the hypophosphorus acid, phosphorus acid, orthophosphoric acid, metaphosphoric acid, hypophosphoric acid, and pyrophosphoric acid, pyrophosphorus acid, and isophosphoric acid. Then phosphorus, then phosphine. These points you will do study in this video. Now start. Point first. What is nitric acid? The formula of nitric acid is HNO3. This is a compound which you used in your laboratory, and I think you know very well what is nitric acid, and you see the bottle of nitric acid in your laboratory. In laboratory, you see the HCl, H2SO4, and nitric acid. Three acids are present generally in table of the laboratory. How to prepare the nitric acid? The simple is that nitric acid, by the reaction of the sodium nitrate with H2SO4, reaction of sodium nitrate and H2SO4, it's give sodium sulfate and HNO3, nitric acid, sodium bisulfate nitric acid. Just look at that. Nitric acid, sodium nitrate, NaNO3, NaNO3 react with the H2SO4. It gives sodium bisulfate, NaHSO4, sodium bisulfate. Then one H is remaining, HNO3, that is the nitric acid. By this method you can prepare the nitric acid. Simple method. It is a laboratory method. Now we will discuss about the industrial method. In the industrial method, we can prepare the nitric acid by the Ostwald process. This is the Ostwald process, most important process. You will get one question in your board exams, so you should know about it. What is Ostwald process? In this process, I would like to tell you point by point. In this process, this process occurs in 3 steps. In this process, first step is oxidation of ammonia. It gives nitric oxide. Okay. Then step number 2, oxidation of nitric oxide, it's give nitrogen dioxide. Then third step is hydrolysis. Hydrolysis means reaction with water. Hydrolysis of nitrogen dioxide. Okay, it gives HNO3, nitric acid. That is called Haber process. Sorry, that is called Ostwald process. By the Ostwald process, you can form the nitric acid. Okay, just see the oxidation of the ammonia gives nitric acid, nitric oxide. Oxidation of the nitric oxide gives nitrogen dioxide, and the hydrolysis of nitrogen dioxide gives the nitric acid. The nitric acid is prepared is 98% pure. Rest is 2% can be purified by the concentrated sulfuric acid. Okay. Now just see the physical property of nitric acid. What is the physical property of nitric acid? Physical property is that, first of all, it is a colorless liquid. Okay, it is colorless liquid. It present in the laboratory in a glass bottle. It is colorless. If it is found in the yellow in color, then you can say it is the impure nitric acid. Means impure nitric acid is yellow in color. This nitric acid is called fuming nitric acid. It's called fuming, FUMING, fuming nitric acid. This the impurity of the nitric acid due to presence of the nitrogen dioxide. Okay, nitrogen dioxide is formed by the decomposition of the nitric acid, HNO3. Now chemical property, and third one is it is corrosive in nature. Corrosive means it done corrosion on any metals. Point number third, chemical property of nitric acid. Chemical property, you know that first of all, nitric acid is acid, so it is acidic in nature. So by the example you can understand acid. If you react any metal with the acid, metal react with acid to give hydrogen gas. So you can see the chemical reaction. Nitric acid react with the water, means this nitric acid is the acid react with the, when you dissociate into the water, it also gives H plus ion because it is acid. Nitric acid HNO3, when you dissolve in the water, it's give H plus and NO3 minus nitrate ion. It gives H plus ion and nitrate ion. Okay, and so we can say that nitric acid produce the H plus ion so in when we dissolve in the water. So we can say that nitric acid is acidic in nature. Okay, when nitric acid is acid in nature, when we react with the base, it gives salt. This is the example. Look at the example. Nitric acid means HNO3. It is acid in nature. When it reacts with the base, NaOH. NaOH is a base, you know very well. NaOH, KOH, magnesium hydroxide, barium hydroxide, all are the base. When it reacts with that, it forms salt. NaNO3. NaNO3. Salt plus water. Salt plus water. That is simple neutralization reaction. NaNO3 plus water. Okay. Now, reaction with the metal. You know that know that nitric acid is an acid. When it reacts with the metal, it produces the hydrogen gas. Look at the chemical reaction. Zinc react with nitric acid HNO3. It's give zinc nitrate ZNO3 and H plus ion. Means hydrogen gas is produced. Okay. This is the chemical reaction is given here. You can see that. And now you can see the write it down some note. Please note it that metals like the chromium and the aluminum do not dissolve in the nitric acid because aluminum is a metal. When it reacts with the nitric acid, it forms the oxide that is called aluminum oxide Al2O3, and it form a layer on the aluminum metal. That's why it prevent the oxidation. Now the another topic is Aqua Razia. Aqua Razia, actually it is a mixture of HCl and HNO3. By the combination of HCl and HNO3, it forms the Aqua Razia. Aqua Razia, it is compound in which noble metals like gold, silver and platinum are dissolved. Combination is Aqua Razia is HCl plus HNO3. The mixture of HCl and HNO3 is called Aqua Razia. 3 part HCl and 1 part HNO3 called Aqua Razia. Okay. Now substitute to next oxidizing nature of the nitric acid. We know that HNO3, H2SO4, KMNO4, K2Cr2, 7 all are the oxidizing acids because it contains the oxygen. So it oxidizes the, in this chemical reaction you can see it oxidizes the hydrogen iodine into the IO3 minus. Means in that case ON number of the iodine is 0, but in that case the ON number of iodine is plus 5. Okay. Now test of nitrate. How we can test the nitrate? You know that when you test with if you talk about the in the practical scenario, nitrate and nitrite, two radicals are present, two acidic radicals are present in any compounds. Okay. First of all, how you can separate it? First of all, you have to take a test tube, then put the sample, add water, that gives you OS, origin solution. Then you have to add concentrated H2SO4. After that, you have to add freshly prepared ferrous ammonium sulfate, ferrous sulfate, that gives a brown ring. That is for brown ring test. It is called brown ring test. Brown ring test represent the presence of nitrate and nitrite ion in the given sample. Okay, that is brown ring. It is the formula of the brown ring is nitrosoferrous sulfate. Nitrosoferrous sulfate formula is FeH2O5 and NO2 plus 2. That is the formula of nitrosoferrous sulfate. Now use of nitric acid. We know that nitric acid is very most important compound. It is used as a reagent in the laboratory, reagent in chemical in so many chemical reactions, compound as a laboratory, as a rocket fuel. It is also used for the formation of the Aquia Razia. By the nitric acid we can form the TNT, trinitrotoluene, and it is also used for the formation of the fertilizer and urea and ammonium nitrate. Okay, now we are shifted to another topic is formation of oxy acids. Formation of oxy acid. Formation of oxy acid. The oxy acids of nitrogens are three: nitrous acid, nitric acid, pernitric acid, and hyponitrous acid. Nitrous acid, the formula of the nitrous acid is HNO2, formula of the nitric acid is HNO3, and the formula of the nitrous pernitric acid is HNO4, and formula of the hyponitrous acid is H2N2O2. Now, first nitrous acid, formula is HNO2. Okay, nitrous acid oxidizes the H2 gas into a sulfur, Ki into I2, and act as the oxidizing agent. In the presence of the strong oxidizing agent, it also acts as a reducing agent. The structure of the nitric acid is nitrous acid is given HNO2. I would like to draw it. Nitrous acid HNO2, HNO2, HNO2. So first of all, you have to form the center atom is nitrogen. Then nitrogen form the triple bond. So that is a double bond, means 2 electron of nitrogen and 2 electron of oxygen. Okay, nitrogen contain 5 electron. 2 electron is there, then it is 1 electron, then it is 2 electron. Okay, then oxygen contain the form double bond, so that is 1 electron and 2 electron, 3, 4, 5, 6. Nitrogen contain 5 electron, 2, 2 and 1, 5. So okay, HNO2, then you can form H here. So this bond is formed, this bond is formed 2 to 4, 5, 6, 7, 8. This bond is formed and oxygen contains 6 lone pair of electron. Okay, so 2 is given, 2 is already formed present in the bond, 2 to 4 and 2 6. Okay, that is a nitrous acid. Okay, now nitric acid, it stains skin yellow due to the formation of the nitro compound xanthoprotein. It is also called as the aqua fortis, meaning strong water, because it attacks almost all metals. I told you it is corrosive in nature. It also forms a constant boiling mixture with the water, which has the 68% of acid. Concentrated nitric acid contain a yellow color on standing. This is due to the presence of nitrogen dioxide, which is formed due to the decomposition of nitric acid in the sunlight. Now, this yellow color may be removed by the warming it or bubbling air through it. For fuming nitric acid contain the nitrogen dioxide in concentrated nitric acid. It is obtained by the distillating concentration nitric acid with the little amount of starch. The structure of the nitric acid is that I would like to explain it. Nitric acid. Formula is nitric acid is HNO3. HNO3. Center atom is nitrogen. Nitrogen forms triple bond, so double bond with oxygen. Then single bond is oxygen and single bond is hydrogen. Okay, triple bond is formed. Nitrogen contains 2 lone pair of electron. Again, after diluting its 3 electron, it contains 2 pair of electron. Okay, and 2 pair of electron is 2 pair of electron donate to the another oxygen atom. Oxygen atom already contain 6 pair of electron. So 3 pair of electron, 6 lone pair. So 2 electrons donate to the oxygen atom. Nitrogen donate 2 lone pair, 2 lone electron to the oxygen atom. So oxygen contains the 8 electron. Nitrogen, and then the bond is formed between the nitrogen and the oxygen is called covalent bond. Okay, the resonance is possible. I would like to show resonance. N O 1 2 3 4. Okay, O H, and then O, then O. Okay, nitrogen donate electron to oxygen, so nitrogen take plus charge and it get the minus charge. It get the minus charge. Okay, now shifting of electron, negative charge shifted to that, negative charge shifted to that, negative charge shifted to that bond, then this 2 shifted to that bond, and now a new structure is formed, that is H single bond O single bond N double bond O single bond O, and it gain electron, this oxygen gain electron, so minus is come here. Okay, this is the resonance occurring in the nitric acid. Now the another oxide of the nitrogen is hyponitrous acid, HNO4. It is a weak basic acid and its structure is HNO4. Simple structure is given here, HNO4 means H2 N2O2. Okay, now the another compound is phosphorus, acid of phosphorus. Acid of phosphorus is given hypophosphorus acid, and orthophosphoric acid, metaphosphoric acid, pyrophosphorus acid, isophoric acid, and the okay, these are the acids of the phosphorus. Now we will discuss all about the phosphorus acid. The structure of phosphorus acids are given here. You can see very well with your formula. Just a simple example I would like to tell you, that is important, it will come in your exam. The question is that, for example, phosphoric acid is given as 3PO3. The question is will be that which type of it is monobasic or dibasic or tribasic. It is what type of basic is that. So the question will be what type of basic is that. If any compound contain one OH, it called monobasic. If any compound contain two OH, it's called dibasic. If any compound contain four OH, it's called tetrabasic. And if any compound contain 5 pH, is called pentabasic. Okay, now the first acid is hypophosphoric acid. It is also called a phosphonic acid. It is a powerful reducing agent because of the presence of the 2 pH bond. Phosphorus acid, it is also called as phosphoric acid. It is dibasic acid. It is in the oxidation state of phosphorus is plus 3. It is oxidizing reducing agent but weaker than hypophosphorus acid due to only 1 pH bond. It undergoes disproportionate reaction giving orthophosphoric acid and the phosphine. Now, orthophosphoric acid. Orthophosphoric acid is also a weak tribasic acid. Means tribasic means it contains a 3 OH bond. It is in the oxidation state of the phosphorus is plus 5. It has no oxidizing, no reducing property. On heating, it gives the pyrophosphoric acid at 525 Kelvin temperature and metaphosphoric acid at 875 Kelvin temperature. So chemical reaction is given here. Now metaphosphoric acid, it is also called glacial phosphoric acid. It is monobasic having the phosphorus in P5 oxidation state. It has no reducing property. It exists as a polymer and thus contain the POP bond which can further form halogen. Hypophosphoric acid, it is tetrabasic in nature. Due to presence of pH bond, it has no reducing property. Oxidation state of phosphorus is plus 4. Pyrophosphoric acid, it is also called as diphosphoric acid. In it, the oxidation state is plus 5. It is also tetrabasic. It has no reducing property. Phosphorus acid, it is also called as diphosphorus acid. In it, the oxidation state of P is plus 3. It contains POP bond as dibasic. It is a strong reducing agent due to presence of pH bond. Now another acid is isohypophosphoric acid. Okay, it contains the 1 POP bond and 1 pH bond. It is also called as diphosphoric acid. It is tribasic in nature. In it, the oxidation state of P is plus 3, which are attached to hydrogen, and rest have plus 5 oxidation state. It has the reducing property also. Now the next compound is phosphorus. Formula of the phosphorus is P. Neha Puja Aslam Sab Bhikari means nitrogen, phosphorus, arsenic, antimony, and bismuth. The formula of the phosphorus is P4. So geometry is tetrahedral. There are three types of phosphorus: black phosphorus, white phosphorus, and red phosphorus. First, we will talk about the white phosphorus, then black phosphorus, then red phosphorus. White phosphorus. White phosphorus is found in a waxy solid state. It is so soft it can be cut by the knife. The geometry of the white phosphorus is given upside in yellow color. The geometry is tetrahedral. You should know about it. White phosphorus is very poisonous in nature. It shows the chemical luminescent, means it glow in the darkness. It most effective reactive from the phosphorus. It undergoes the disproportionate reaction, means when the phosphorus, means P4, react with the white phosphorus, P4 react with the base NaOH, is produced phosphine gas, PS3. It is highly poisonous gas. So I would like to tell you, white phosphorus is highly reactive. Phosphorus sodium hydroperoxide. In this oxidation state of phosphorus, charge from +1 0 to 0 to +1 and +3. Now black phosphorus. Black phosphorus exists in two states: alpha black phosphorus and beta black phosphorus. Okay, alpha black phosphorus and beta black phosphorus. Alpha black phosphorus is formed by the heating of the red phosphorus at 803 Kelvin temperature, but white phosphorus is formed by the heating of the beta phosphorus is formed by the heating of the white phosphorus at 473 Kelvin temperature. Now the red phosphorus. Red phosphorus is formed by the heating of the white phosphorus at 573 Kelvin temperature in inert atmosphere. Its structure is given, that is the red phosphorus. Okay, all the three molecules of phosphorus P4 are combined together. It is a crystalline solid. It is shiny in gray. It is non-poisonous. It is more stable. Means white phosphorus is poisonous, but red phosphorus is not poisonous. It is also shows the chemical luminescent. It is not highly reactive. It is highly stable. So we can say that white phosphorus is less stable, then red phosphorus is highly stable, and black phosphorus is highly stable. And the another compound is phosphine. The molecular formula is phosphine is PS3. Phosphine is generally formed when the white phosphorus reacts with the NaOH gives a phosphine. Structure is phosphine is given. Phosphorus contain the 5 lone pairs, lone electron. So 3 electron is donated to the hydrogen and it contains the 1 lone pair of electron. How it can be prepared? It is prepared by the dropping water on the calcium phosphide. This is the chemical reaction. When the calcium phosphide Ca3P2 react with the water gives the phosphine. Okay. Now the laboratory method, how you can prepare reaction of the phosphorus, white phosphorus with the NaOH, it gives the phosphine. Okay, this is the simple method of preparation. Now what is the physical property of phosphine? It is the colorless, odorless, colorless gas with the smell of rotten fish. Okay, it is colorless gas, but it smell like a rotten fish. It is highly poisonous in nature, highly poisonous. It is slightly soluble in water because it forms the H bond. The solution of the phosphine is unstable and decomposes in the presence of the sunlight. Now the chemical property of the phosphine is, I think you know very well what I am telling you, and if you are unable to understand, just see this video again and again. And chemical properties that I would like to try myself, I will explain you in the proper way, and you will be satisfied with my study. Chemical property, it is weak basic because actually NH is called ammonia, but it is also a weak basic, and phosphine, its formula is PS3, it is also a weak basic because due to lone pair of electron, it undergoes the participation reaction, that is copper sulfate react with the phosphine give the copper phosphide. Okay, as silver nitrate react with the phosphine give the silver phosphide. Okay, now the use of the phosphine is, I know phosphine is very highly poisonous, but it also has some use. First use is combustion of the phosphine is used in the hallmark signals for the ship. You can see the hallmark signals in the ship. The ship these signals contain the phosphine gas. It is also used as a smoke screen in the warfare. Okay, for smoke screen. Now this video is finished. We are going to do some important question. Question number first is, explain the Ostwald process. By the Ostwald process we can form the nitric acid. Question number second, explain the acidic nature of the nitric acid. Most important question. Explain the physical and chemical property of the phosphine. It is also most important question. what is black phosphorus, and question number 5, explain acidic compound of the phosphorus with their diagram. All the questions are given here are very important, and this question is made by me according to your CBSE and RBSE board, and it is not your textbook question, but you have to do in your notebook. After your school reopen, we will check it as your homework, as your homework. Okay, thank you so much for watching this video. I hope you understand very well this video. If you are unable to understand, please watch this video again and again, you will understand, and if you have any doubt you can ask me. Okay, thank you so much. Bye bye for watching this.